Hello and welcome to R&D Mathematics. Today we are going to talk about parametric equations. Now, let's say you have a curve like this. Now, this graph actually is not a function because if you draw, vertical lines, it fails the vertical line tests. So there is no way you can write down this as y equals f of x. Then what? Now imagine this is the path of a small fly flying, say small fly flying on the plane like that. So how can we write mathematics about this? In this case, we are going to introduce this one. So x equal function of t, y equals another function of t. Now the idea, for example, you can think t as time. In most cases, in physical applications, in physics, it is time. But normally we call t as a parameter. So using a third variable, we actually get rid of this problem. Now let's see some examples, then you will understand this. Now let's say you have to sketch. Let's say you have to sketch x equal t squared minus 4 y equals 2t. Now in this case, see, x is denoted as a function of t and y is denoted as again function of t, another function. And let's say t is in this range. Now with this kind of notation, with this new technique, we have control over many things. Now let's make a table. T, x and y. So t is ranging from -1 to 2. So let's say -1, -1/2 and 0 and then 1 and 2. So what are the x and y values? X equal t squared minus 4. So -1 squared, which is 1 minus 4, -3. And for -1/2, -1/2 squared, which is 1/4 minus 4, that is -15/4. 0 squared minus 4, -4, and 1/2, again you get the same value as 1, -3, and then 2 squared, which is 4 minus 4, 0, and y equals 2t. So -2, -1, 0, and then 2, and then 4. Now if you draw this now all you need to do, plot x and y and draw it. So -3, 2, somewhere here, and then -15/4, that is about -3 point something, so somewhere here, and -1, -4, 0. So you have, see, this one is -4, 0, so it's going through this, and -1/2, this value is little above 3, so if you draw this, you are going to get 0, 4, a value like this. So this point, -3, -2, so -3, -2, and yeah, so this point is this point is this point is this, and you simply point plot. Now see, we draw a part of a curve, and also it is important to write down the direction because we start from -1 and we go up to -2. So this is the beauty of this technique. You can draw directed line, curve segments as well. Now, if you change this, for example, if you change this from negative infinity to infinity, in this case, your line would be, a parabola like this, going forever. So this is just a part of it. So that's the idea behind, that's one idea behind parametric equations. And let's see another examples. Now let's say sketch x equals sine pi t over 2, y equals t. Now in this case again, make the table t, x and y. So let's say t is changing from 0 to 6. So what will we get here? So let's write down t equals 0, 1, 2, 3, 4, 5, 6. And now with this, so first one, sine 0, 0, 0, sine pi by 2, 1 and 1, sine pi 2 over 2, which is sine pi. So you have 0 and 2. See, y value is same as, because y equals t, y value is same as t. So we can make that. And for x values, it's multiple of pi by 2. So we are going to get here, since it's odd, negative 1, and then 0, 1, 0, negative 1, and so on. So if we draw this, let's say 0, 0, and then 1, comma 1. See, this is just a third variable, and we are not drawing that. That is just to help us. We are actually drawing it in xy plane, because these are plane curves. The idea can be extended to space curves as well. Okay, so x 0, 0, then 1, comma 1 somewhere here, then 0, comma 2 here, negative 1, comma 3, so negative 1 here, so 3 here, and then 0, comma 4, and then 1, comma 5. Now we see the pattern. It is going, and this is a sine curves. So since we have sine, so it's going like this, and last one 0, comma 6, so 0, comma 6 right here. So we don't have that anymore. See, this little part of this curve is denoted by this parametrization. Okay, I think now the idea is actually clear. Now, in some cases, you may have to draw the table and do it, but in some cases, you don't have to actually. Let's say x equal a cosine t and y equals a sine t. A sine t. And t is changing from 0 to 2 pi. Now, in this case, how do we draw this? Well, yes, you can draw the table and do it. But if you can find the relationship between x and y, or if you can get rid of t. And how do you get rid of t? So what can you see this? X squared plus y squared. Now this is the experience. A squared cosine squared t plus a squared sine squared t. Now a squared can be taken out. Then you have cos squared plus sine squared. That is always 1. This guy is 1. So x squared plus y squared equals 1. Sorry, a squared. That means this represents a circle with center 0, 0 and radius a. And why? Because it's 0 to 2 pi. And for example, now let's draw the table, not the whole of the table, but some part of it. Let's see the starting point and ending point. When t equals 0, x value is a cosine 0, which is a, because cosine 0 is 1, and y value is a sine 0, sine 0 is 0, so a comma 0, and 2 pi, you have the same story, a is 0. And just to be clear, just to get the direction where it starts and where it ends, let's take pi by 4 or 45 degrees. So cosine, no, let's take 90 degrees. Cosine 90, that is 0, and sine 90, that is 1. So we have that. That means this point. So we start here and we end at the same place, and we have this. That means we are going in this direction. So we go here and come back. Now in this example, we can talk a little bit more nice things. What if you have to have this part, the upper half circle? In that case, you just need to parameterize it like this, right? And if you want the lower half, and if you want the lower half, well, if you go like this, then, well, we have to go with minus t, because t is normally when you take sine and cosine, angle is counterclockwise. So if you go with minus t, for example, you can do cosine minus t here and sine minus t, then it will change the direction. So things like that, we can do things like that in this parametric stories. Now let's see more examples. Seeing more example is the easier way to deal with this. Now let's say, how about this, another example. X equal t, y equals 1 minus t squared. Now in this case, let's say t is in between -1 and 0. Now here, how do you draw this? Well, so x equal t, so it's pretty easy. Y is going to be 1 minus x squared because of that, and then the square root. And -1 between t and t is between -1 and 0. Now, this one, well, if you can remember, that's a certain shape, but if not, what you want to do, square it, 1 minus x squared. So when you take x squared to the left hand side, x squared plus y squared equals 1. Now this guy is a circle. Now this is a nice example to show you a few things. This equation is a circle, but this equation is not quite that. That's just part of it. That's going to be the, see here we have, when you have square root sign and when you don't see any sign in front of it, that means you have the plus sign. If you have specifically minus sign, you denote it like this. So since we have plus sign, that's only the upper half. But now we have to be careful. This is still not our final answer, because see, in this work, in this piece of work, I never use this fact. So t is only changing from -1 to 0, and x equal t. That's how we parameterized it. So without drawing the table, since x is t, we have here x is only changing between -1 and 0. So -1 and 0. So -1 here, 0 here. So we are actually talking about this part. Yeah, actually talking about this part, and the starting point is -1, t equals -1, but in this case, since x is parameterized as t, x also starting at -1, so it goes like this. I hope that example makes sense, right? And yes, I think that's enough examples for today's video. Thank you.